So great, I'd like to welcome everyone to Polygot Java EE on the GraalVM. So this presentation I'm actually very excited to give. I think Graal's impact on Java EE is going to be huge. It's going to drive a huge amount of innovation in Jakarta EE in ways that we never thought possible or really couldn't create solutions without this particular technology. So I think it's going to be very impressive going forward to what this is going to do to the platform and the capabilities that it gives us, which is the reason why I'm very excited by it. So for those of you that aren't familiar with GraalVM, it is an open JDK distribution from Oracle. Currently it's supporting Java 8 Update 12. Oracle technologies are not included with this, so if you are using WebStart or anything else that is Oracle specific, this is just a pure open JDK build. There are two editions of it. There's an enterprise edition and also a community edition. Both of them are they're both open source, or at least the community edition is, and there is no fee for actually trying it out, and the community edition can be used in development. GraalVM enables Polygot development in JavaScript, Python, R, Ruby, C, C++, and you can even create and add your own languages to it. So there's been quite a bit of discussion online. I know that there's some people that are working with the IntelliJ MPS to create their own languages to run on top of GraalVM. Also, interestingly, it can generate native statically linked executables. So it can take your existing Java application and turn that into a native application where you do not require the JDK to actually run it. It is a single statically linked executable that you can copy around, deploy, and run, etc. So it is a drop-in replacement for the JDK. Now this is a little confusing with what's been going on because the last couple of years with the licensing changes from Oracle, we've had a proliferation of different open JDK distributions available. So we have GraalVM, of course, we've got SAP Machine, the Java release from Oracle, Liberica, Azure, Amazon Corrado, OpenJ9, OpenJDK itself, and also adopt OpenJDK. So it's a little confusing. So what is the relationship with GraalVM to these, and does that mean that Oracle is going to eventually just go all GraalVM? What does that leave the OpenJDK, etc. with that? So this is at this point in time, it's very confusing what's going on with the JDK distributions and which one you should choose and what are the relationships between them. So GraalVM versus the other OpenJDK distribution adds additional languages. So it adds JavaScript, R, Python, Ruby, etc. It has a different JIT compiler that's actually implemented in Java, which is right now, according to the metrics, supposedly giving excellent performance. As I mentioned, it can generate native images, and it has the ability for something called isolates, which basically means you can run multiple VM instances in process, which is a very interesting thing to look at, and the capabilities that hopefully the Java EE containers will take advantage of this in the future. But that's how GraalVM distinguishes itself from the other OpenJDK distributions. It really is a different beast. It is OpenJDK, but it's got this extra stuff on top of it. So why GraalVM? Well, interoperation with other languages has traditionally been very painful and high impact. So if you've ever tried to interact with C code via JNI, you know what a rat's nest that can be. The challenges that you can run into doing that. Also, the process API is extremely painful to work with. Also, Nashorn can't keep up. So if you've tried running JavaScript on Nashorn, you realize that it's stuck about 5 years ago. When Nashorn was developed and released, JavaScript was releasing, every 10 or 15 years there were changes being made to it. Now every year JavaScript is changing, and Nashorn's approach of compiling JavaScript down to bytecode hasn't been able to keep up and is extremely resource intensive to maintain, and hence the reason why it's being dropped. Also, Java can't, another reason for GraalVM, Java can't compete with serverless. The startup time is too long, the image size is too big. So with GraalVM actually makes that much easier with its native image capability, which generates statically linked executables. So now Java can be a player in the serverless area, right? So we have that instant, with GraalVM produce native executables, we now have instant startup, etc. So the architecture overview, this has been shown many times, is the general architecture. You have the GraalVM in the between. It compiles down code. It uses LLVM underneath the hood. So it can take and run Java code, Node.js code, it can run in a database, it can run standalone, it can run all the languages across the top, not only Java, it can also run the different JVM languages, but it also gives you these other languages such as JavaScript, Ruby, R, Python, and their native libraries that comes with them, including C and C++. So the components of the GraalVM, so you have the GraalVM compiler, which is a just-in-time compiler implemented in Java. It's like C2 and Hotspot. You have the Graal native image component, which is an ahead-of-time compilation technology that produces executable binaries. The Truffle framework, which is a framework for implementing languages on top of GraalVM. And then finally, instrumentation support. So there's actually a language-agnostic debugger, profiler, and heap viewer tool chain that's available with it. So if you're trying to debug your JavaScript Python code that's running on top of the GraalVM, you'd actually you start up with the -- inspect and you hop over into Chrome and use the Chrome developer tools to see what's going on within your code. So those are the components to it. It's two other components that in reading documentation you'll come across. The Substrate VM, which is the ahead-of-time compiler, which turns regular Java executable into a binary. And also Sulong, which is the high-performance LLVM bitcode interpreter built on GraalVM. And these are all underneath the overarching Graal project up on GitHub. So the Graal runtime pieces, we have the Java hotspot with the Graal. So we've got two runtimes immediately available, the Java hotspot VM with the GraalVM compiler, the Node.js runtime with the GraalVM JavaScript interpreter. Those come with it out of the box. And then you've got the libraries, which are just the different jar files with the GraalVM compiler, the JavaScript interpreter, the LLVM bytecode interpreter, etc. And then you've got a series of utilities, the JavaScript REPL, the bitcode interpreter, and also the GraalVM updater. So those are the three main pieces. And so, one of the questions that comes up is, why do we need non-JVM languages? Isn't there enough innovation going on in the Java platform right now with Kotlin, Groovy, name the language that's going out there? And the answer really is no, because if you look at this does not include C++ libraries, but if you look at the packages that are available in other languages out there, Node has got, I think, almost 500,000 packages, equivalent of like jars that are available out there that implement different functionality. Python's got a huge number. And so Java, it only comprises about 30% of the libraries that are available. So if you're only programming in Java, you're limited to less than 30% of the open source libraries that are available, not including C and C++. So what GraalVM is doing is it's opening up all of the other libraries for you to be able to use in your applications, and opening that up to the Java EE platform with new opportunities. So the libraries in many of the other languages, now once Graal is actually completed, you'll eventually have access to things like TensorFlow, NumPy, Express, YAML, ggplot, etc. So suddenly all of these libraries that are in the different languages that you'd have to learn those languages in order to use them, they will now be available on the Java platform itself. So this is why this is so exciting, is that now you're not limited to just the Java ecosystem. You can take advantage of the entire ecosystem out there, from Python, from Ruby, from R. Right? So it allows you to hop between the different languages. So this is the really cool thing about this, and I have some demos as we get through the presentation where I front-end a Java EE application with Express running on Node.js. So it opens up it opens up numerous possibilities that we didn't have previously. And so the question is, why Polygot? This is from a presentation I did several years ago on R. Because if you're trying to implement stuff like this in Java, it can be extremely painful. There's better languages, like doing this type of stuff over in R is much better, right? So Java is basically a general purpose language where some of these other languages have focused on specific niches. So if you're doing statistical programming or statistical analysis, R is a better language to work with. It's got a ton of built-in functionality. Statisticians, actuaries, etc. know how to work with R. Right? So you can get stuff to them. You don't have to translate stuff into Java. Over the course of years, I've translated a couple of stats functions over into Java, and unbeknownst to me, in one of the cases, I actually made a mistake, which was easy to make in Java. Didn't catch it until after it shipped, but it would have been much easier implementing that same function in R, which is more, fluent. It has a better fluent API for doing that. So really the bottom line is to use the best tool for the job, and with GraalVM, you're not limited to just Java anymore. You can take advantage of all of the other languages and the features that they offer. So some common questions: can Java already run JavaScript, Python, Ruby, etc. via Nashorn, Rhino, Jython, and Ruby? Yes, but with lots of limitations. So the JavaScript support that's built into Java right now with Nashorn doesn't allow you to run NPM modules, right? This is one of the things that the GraalVM gives you. You can't pull in Python modules. You can't pull in, Ruby gems, right? So it's very lightweight, and it's also compiling it down to Java bytecode, which you take a bit of a performance hit. So if you've ever noticed that the JavaScript running in Nashorn is much slower than the JavaScript that you get out of the V8 engine for JavaScript, several orders of magnitude. Was Nashorn killed because of GraalVM? The answer is no. I've discussed with different people, I have run into different people that have thought there was a plot by Oracle to kill Nashorn and release GraalVM. That's not the case from as far as I can tell. There's actual architectural limitations with Nashorn which have become more pronounced now that JavaScript has continued to add features every year, right? So it's gotten much harder for them to keep up. So GraalVM takes a completely different approach because it basically compiles it down to native code, down to bit code. Doesn't try to transform JavaScript into Java bytecode with all the limitations that implies. Native libraries are what's wrong with JNI. Well, JNI is extremely painful to work with, to try to call into other languages using it. I was told years ago that that was actually designed on purpose so that it would be hard so that you try to do everything in Java so you wouldn't try to go against other libraries. Is the native client capability in GraalVM related to JLink? The answer is no. And the nice thing about the native client support in GraalVM is it doesn't require that you modularize your applications, right? So in order to use JLink, all of your dependencies have to be modularized, Java 9 modules in order for you to use JLink, and then JLink produces you a JDK with your application with just the libraries that you use. It doesn't produce a nice single file executable for you to use. So the barrier to using JLink is much higher than it is for using the native client, right? So I've spent, with the sample application I was trying to do using some of the Java EE technologies, well over 12 hours trying to get that to go into JLink, right? Whereas I can take the same thing with the native client and mostly get it. There's some caveats with that. With Grail, can I leverage native libraries, etc.? Yes. Does it require a commercial license to use in production? No. So you can use everything that I'm covering in this presentation in production without buying a license. What platforms are supported? Currently only Mac and Linux. And do existing Java EE, Jakarta EE containers run on GraalVM? The answer is yes. So you can take your existing Glassfish, Pyra, TomEE, Tomcat container, and you can run it unchanged, unmodified on GraalVM. There's really no difference. It's the baseline Java, and put your container on it, and you get all of the additional features with it. Okay. So what are the possibilities with GraalVM? So you can directly from Java invoke R. You can invoke Python from Java. You can invoke Ruby from Java, and that's bidirectional. Invoke JavaScript, C, and also C++ code, which means that you can actually use shared libraries. There's an example online that I have a link to at the end of the presentation where somebody has actually wrapped the native libraries for SQLite and is accessing those directly from Java, right? And it's trivial to do. So these are some of the possibilities working with all the languages directly. But you can also use JavaScript to invoke Java that then turns around and invokes R. So you could have some JavaScript code and an Express application that invokes some Java code, which in turn invokes some R code, all running within the same VM, right? So it's not just one direction. It's not just Java running something else. It can be something else running Java as well. So your JavaScript developers can now have the full access to the power of Java. They can write their code over in JavaScript and then call out into Java code and execute stuff. And your Java code can be turning around underneath the hood and running R code without them even knowing or having to be aware of it. So there's some incredible power with this. The same thing, you can embed something in a C program that calls R code, which calls Java code, right? Or you can do something along the lines of Node code invoking Java code, which is then using Ruby code for something underneath the hood. So these are all the possibilities that GraalVM opens up to you. So it's really, the sky's the limit with this thing. So now, GraalVM with Jakarta EE. The Polygot expands the Java ecosystem possibilities exponentially. So it allows us to unify enterprise architecture. So now if you have some system that's written in Python, you don't have to run that separately. You can actually run that within the JVM. You don't have to do a process.execute. You don't have to send it off to some other server or come up with some way to interact, have it expose services, etc. You can actually use it in process. This opens up the capabilities, for example, JavaScript library. So we have JavaScript validation on the client side, and then server-side validation, which is performed usually in a completely separate code base, right? So you'll have UI on the client side implemented with JavaScript, and then the same data model is being checked on the server side with Java. Now with GraalVM, you could have a library that works on both. You could have a JavaScript library that the browser loads and uses to check the UI, the data coming out of the UI, and you could use that same code in the server so that you wouldn't have to keep two different languages in sync, two different implementations of validation checks in sync. You could implement it just once. And you'd have no clunky interrupt packages. So for example, in the past, if you're trying to use R, there were some R packages that allowed you to work with Java. Those were very clunky, hard to work with. I did a presentation on that years ago, and just trying to keep it stable where it wasn't crashing was a challenge. In summary, it simplifies the runtime architecture and coordination of your application. It allows you to use these different technologies without having to, invoke processes, call out to other things. So for example, you can have a Node Express application. So this is the first application I'm going to demonstrate. Node Express application invoking Pyra. You can also have a Jakarta EE application that's using R and C code underneath the hood. Right? So these are some of the possibilities that you have with it. And we're actually going to see both of these in the presentation today. Installing a GraalVM is actually pretty dead simple. You go to the website, you click download. There's also a Docker image and some online videos for how to use that. So either one of those approaches. And remember, it's only available for Mac and Linux currently. Installation is a cinch. You just download the tar file, unzip it. Copy it if you're on Mac OS X, you copy it over into your Java virtual machines. It does work with JENV, which is what I use for managing 5 or 6 different JVM implementations on my machine so I can hop between them. So you can just do JNV add your GraalVM, it shows up. And also set the Graal home environment variable, especially if you're going to be working with native code and invoking compilers with native code, because it just makes it easier to use. The one caveat that I would point out with is to avoid installing it as root, because when you install basically additional languages on top of it, if it's installed as root, then that becomes a little bit tricky in terms of trying to get the packages down. And the error messages can be a little opaque at that point. The next thing after you download it and install it, if you're using Maven, is to set up your Maven toolchain to specify the Graal location for it. And then once you have it, you can verify the installation. So it looks just like an OpenJDK build. The only difference is it's going to print out, GraalVM 19.02. And then if you're using JNV, most of the rest of the tools are only going to see it as Java 8. Update 12. They're not going to see it as some different JVM implementation, right? So as far as your tooling and everything else is concerned, it's just another release of Java on your system and behaves as such, right? So the differences between the JDK and what comes with GraalVM. So the JavaFX packager and also JMC are removed, and these following command line utilities now appear in the bin folder of the JDK. So you've got GU, which is for updating or installing packages, such as R, which is a separate download, JS for running JS stuff, your Node, NPM, and also your Polygot commands. So all of these come with it. So these are additional commands that come with it. Then you can use the GU to basically, it's a package manager to install R, Python, Ruby, and also the native image capabilities. When you do that, after you run those installers, if you're using those technologies, then you'll have more executables show up in your bin directory on your path for Ruby documentation, for generating the native image, etc. Okay. And then debugging it is pretty straightforward. Debugging applications, you just run, if you're running a Node application, you just do -- inspect, and take and paste the URL that it prints out into the Chrome web browser, and that opens up the debugger, and then from there you can debug your JavaScript code running a Node, you can debug your JavaScript code that's calling Ruby code, etc. All the debugging is done via Chrome. So it's very straightforward. It's nice that you have only one debugging tool that you have to worry about. Okay. And then in terms of setting up your Java project, so you have an existing Java EE application that you want to take over to GraalVM. How do you add it to the class path? Well, the first thing to do is to add the reference for your toolchain. So in this case right here, this reference is my toolchain. So I say I'm using the version GraalVM Oracle. That's what I put in my toolchain file, my M2 directory that I showed previously. And then the Maven coordinates for the GraalVM and also truffle. You need both of these on the class path in order to use it. And a note with the dependency for GraalVM, it actually references a system path, so that's something that's going to be specific to your machine, which specifies where it can find the Graal SDK.jar that it's going to need. So this is a simple example hello world application where I'm firing up in a Java main method, calling out to JavaScript to execute hello world, and printing out hello Devoxx. So up at the top we have the Java code, down at the bottom we have the JavaScript code. It's fairly simple. Let me hop over and run that. Well, that's not supposed to happen. Oh, I'm in the wrong directory. Okay. Well, I have a syntax error, but it ran really quick. What did I do here? I'll figure that out later. I was taking screenshots for the slides, so I probably broke it. Anyway, it runs extremely quick, so you can see how fast it started up. Now, if you converted this over to a native image, it would run even faster. Okay, so that's a simple hello world example, and that's the basic code in order to invoke JavaScript. Now, from within JavaScript, we can then turn around and invoke other languages. Now, the API for GraalVM is split up into a Polygot. It's split up basically into 3 different packages. Polygot, which contains allows you to configure and run other languages, etc. Proxy, which allows you to mimic guest language objects using proxies. And also IO, which allows you to customize the file system access of the different languages. So those are the 3 main packages that you interact with. It's actually a surprisingly small number of classes that you actually work with, unless you start getting into implementing your own languages on top of the platform. The key Polygot classes that we saw on the previous slide was context, which is the context for the guest language to evaluate code. The engine, which is the execution engine, which enables inspection, etc. Source, which is just basically a source code unit to be evaluated. And then value, which is what you get returned every time you do an evaluation of some code, right? Call a method or etc. It gives you this value object back, which you can then drill in and get the values that were what the language had done. So it's an agnostic API for the different languages. And then in terms of the individual languages, R, Ruby, Python, JavaScript, etc., each one of those has a set of functions that it adds to the language so that you can either communicate back or kick off another language. So for example, you're running R code, you can then turn around and invoke Java code, you can invoke JavaScript code, etc. So there's some baseline things that they add to each one of the languages that then allows you to turn around and evaluate or to export stuff back to Java into the program that was calling it. And the documentation up on the website goes over all of the different things. In terms of interoperability with data types, in each one of the languages you can use your Java objects. So in JavaScript you first define the Java type, var big integer equals Java dash type, and you pull in your type. So that's how you get the Java types into the language. Same thing for R. As well as Ruby and Python. Should mention that R has additional capabilities in terms of handling graphics, which makes it easier to handle plots, etc. C and C++ interoperability, there is a Polygot header file which allows you from C or C++ code to then kick off Java, R, any of the other languages. And then compiling it down below, you specify the location. The include file comes out of the Graal JDK. So these are just a snapshot of some of the functions that are available. So you pull that in and then you can turn around and wrap your existing C code, call off to C code, etc. There's also, because Nashorn is being deprecated, they also have Nashorn interoperability. So you can actually specify when you get the scripting engine, you can say, well, I want the Graal JS script engine, right? So you can continue to use the standard JavaScript API that Java has had for a while, but have Graal underneath the hood performing the JavaScript code. So moving on to Jakarta EE and Graal Hello World. So the demo application I'm going to show off is a Jakarta EE application running on Pyera Micro. Pyera Micro is basically a Java EE container. It's Glassfish in a single jar file. It's only 70 megs. The functions, I implemented functions in each one of the language that accepts a parameter and returns a message. And it uses a warm-up bean, startup singleton bean, to warm up the different languages so that everything's up and running, so when I go into the web page, everything is nice and fast. And the languages that it supports are R, JavaScript, Python, Ruby, and C. So with that, let me hop over back to the IDE. So the first thing to note with this, and all of this code is checked into GitHub. We have our POM file, which has the stuff that I went over just a minute ago. We have some C code, which does hello world. So it takes a name and basically says, C says hello world and takes in the name that you passed in and returns it back. We can ignore the main method that was just for testing. The run.sh basically does compiles that, so it uses Clang to compile it, passing in the header files. So if we go back there, you can see where I'm including Polygot. And then I package it up and I run it using Pyera Micro. So we have, I copy over just to make it easier for it to find it, I copy the output of the compilation of the C code into the resources directory. We have our hello world JavaScript, our hello world Python, hello world R, and Ruby. And this was a fun presentation to put together because I had to not only work in Java, but all of these other languages. It's been a while since I've done C. If I run the application, loaded it. Okay. Loaded, so I'm going to enter in. That was fast. That was JavaScript. Let's do R. R says hello. Python. Python says hello. Ruby. And then finally C code. So that was really easy, right? I was able to interact with all the different languages. So if I look at it, I have warm up, which is a startup singleton bean, which basically just gets the context going. Actually, I kick off a I kick off one of the JavaScript ones just to get everything warmed up. And then the code that performs this is over here. So I load each one of my scripts, do the evaluation. When a request comes in, there's a method for each one of them that does the evaluation. So as you can see, interoperating with these different languages is absolutely trivial in the container. And this is all running inside of Pyera, Pyera Micro. You can run this inside of Glassfish, Wildfly, WebSphere, WebLogic. All of these it'll work with. So you can now call out to Python functions, etc. Okay, the next one I think is a little bit more exciting. In this one, I actually wrap up Pyera Micro, the Pyera application server, EE application. It's an EE8 application server with an Express Node.js front end. So Express is a web framework for Node.js. It's an easy-to-use framework for developing web apps. It's actually trivial. So the application actually starts in Node. So I'm not actually running Java initially. I'm running Node. The Express application starts up. It then fires up Pyera Micro, deploys the application, and then calls in specifically to invoke methods on the Java EE side of the house to call stateless session beans. And so if you're unfamiliar with Express, as I mentioned, it's a minimalistic web framework for Node.js, fairly popular, and it's much easier to implement some baseline functionality with this than trying to implement the same stuff in like Tomcat, for example. So this is just an example application. I fire up Express. So on the top line is a require for Express, set up my different routes, the URLs that it's going to respond to, and what content is going to be returned. So if you hit port 80, / or in this case port 3000 / it returns get the request to the home page, etc. down below. So this is very, very simple framework to work with. So that's Express. Now let's hop over and take a look at the Express application. Not that one. Okay, so the Java side of the house, which is a bootstrap, I actually fire up. Pyera Micro has an embedded API. So I actually take and wrap up all of the code into basically a jar file containing Pyera. And so Pyera fires up, and I deploy my WAR file. I set the port to 9000 for the web hosting, and then bootstrap it. And then when a request comes in from the Express side, I go in, I look up my enterprise Java bean, and I invoke it. Now this is just a real basic, bare bones example just to show you how you'd hook it up. Production code would of course be a little bit different, a little more streamlined, but this is the basic idea. So I fire up Pyera, the application server, I deploy my WAR file, and then I have methods on this class, which is the JavaScript code is going to call into to invoke it. If we look at this project, we have a package JSON. Where I specify my Express dependency on 4.17.1, right? We have a POM file for building, and then let me open up the server.js. So this is the Express application, really simple Express application. So I start up requiring Express. We're on port 8080. I start up the Pyera container, so this is using the JavaScript bindings provided by GraalVM to get a hold of Pyera Micro. So this is the code that we just saw that fires up the container, deploys the applications, and provides the interface for calling into it. And then I have, on the response, when I render a response, when a response request comes in for /, I call off to the Java code and say, okay, give me some content to send back to the client. Okay. And then the actual run code, run script, I'm invoking Node. Notice here I'm not invoking Java, so it's actually Node invoking Java. So I'm going to start up with Node. It's the node that's provided by the GraalVM installation. I start it up. I pass in the inspect if I want to debug it, pass in --JVM to let it know that I'm going to be using Java. I ran into a bug where I had to specify, this is how you pass in parameters to the JVM, so I want it to be headless. I ran into a bug on OS 10 where sometimes it would crash if it was not headless. Actually, I traced it down. It was trying to load up the icon that would appear in the dock. And then specify the class path for my Java application, that it's Polygot, so we're going to be running multiple languages, and then to execute server.js, which you just saw, which is the Express application. So if we go ahead and run that, so let me kill the other one first. It's compiling. Okay, now Node.js is starting up. Pyera is actually, so you can see the output from Pyera is being routed through Node.js and out to the command line. It takes just a second for it to start up. Okay, so it's running on port 8080. Hello world from Pyera Micro. So we have in this case we have Express invoking a Java EE container. So the Express is actually wrapping a Java EE container. It's pretty neat. I don't know if I'll put it into production yet, but this is what's possible with it now. So the next example is a Jakarta EE plus Python. So this is a little bit more complicated, demonstrating some best practices. So in this example, I'm actually going to load data out of a database using JPA, pass it off to Python to have Python make some changes to the data, and then the data gets flushed back to the database without having to do any translations. And also I demonstrate, because sometimes the scripting languages underneath the hood take off on you, wrapping using CDI to basically intercept the calls to GraalVM so that we can apply a timer on it, so that if the language runs amok, it takes, the script has goes into an infinite loop or something like that, it will kill it, which is the best practice. So this is a simple, fairly straightforward application. So I've got a data cleanup bean, which I'm working with road races, which retrieves the road races from the database, and then calls a Python script to actually do the cleanup, right? So I retrieve from the database a bunch of road race race participant objects. I loop over them in Python, and the Python code is right here. With some little line there to make sure that it was actually executing. But I set I kept it simple, and I set the participant last name to their name property that was passed, and the idea would be that Python would be splitting the name, the data set that I was working with had it just as the full name, so I wanted to split the first name and last name. But this is a Java object that's getting passed in, and it's not a proxy, it's the actual Java object, and Python is working with it. So when this code makes changes to it, it's actually changing the Java object which JPA has produced. Now JPA will notice that the object has been made to it, so that when this method returns, the transaction wraps up and the data gets persisted back to the database. So here I have Python manipulating JPA entities and those entities being seamlessly flushed to the database without me having to do any work. So there's no interop layer that I had to implement in order to do this. I didn't have to pull the data out of the database in Java, then convert it into Python objects. That was done for me. So Python is actually working with the representation of it, directly with it, which is pretty cool. And then in terms of the Graal timeout, I have an interceptor binding for a GraalVM timeout. If we look back at that data cleanup code, I have the annotation right here specifying that I'm using a timeout interceptor. And then I wrap it, I inject the context into the interceptor, and then I kill it if it takes too long. So this is if you're working with GraalVM, you're executing other languages, you might have to at some point kill things when it runs amok. I ran into some scripts where the thing would just go off into Never Never Land, and I had no way of actually killing it without killing the process. So this is a way that using Java EE you can interact, provide a better interaction with it. And as you can see, I'm using CDI to inject the context to work with that in different parts of the application. I have a Python context into which I've loaded, so this context right here is for the Python scripts that I've loaded. So that example showed how you can use CDI interceptors to catch runaway scripts and also seamlessly pass data between JPA and Python and have the Python actually make changes to the JPA objects, and they just get persisted back to the database without you having to do any work. Now, GraalVM opens up a whole host of opportunities for Jakarta EE going forward. Perhaps going forward, as Jakarta EE continues to evolve, Jakarta EE will no longer be limited to Java. We could have non-Java bindings for other languages, so you could have C++, EJB, singleton beans, CDI beans, etc. There's a whole host of things that we can actually do with this. Dependency injection for non-Java objects. Isolates, which are really interesting. So an isolate allows you to have multiple independent VM instances within the JVM that you can control. It improves security. It also means that if one of them crashes, it doesn't take down everything. So if you look at right now, your Java EE containers are implemented using class loaders, where each application basically gets its own class loader. The containers were re-implemented differently using isolates. This would actually allow the applications to be completely isolated and improve fault tolerance, etc. Also reactive support. So JavaScript has got really good support for reactive APIs. You've got the Mongo database driver, which is reactive, which is available to JavaScript. It isn't quite there yet on the Java side. So you could actually use, so if you want a reactive driver for MongoDB, you can now use that from Java. You don't have to use the JavaScript one from Java. You don't have to wait for it from JavaScript. You don't have to wait for it to be ported to Java. You can use it today, right? So it gives you, APIs and libraries that, that they didn't have access to before. So there's many possibilities going forward in terms of how the technologies can be used. Now, challenges and limitations, and this was a very frustrating presentation to actually work on some of the code examples. So the window distribution is incomplete. So Windows isn't quite there yet. There's some early release builds of that. Building and packaging multiple languages tends to be a little bit challenging. So I wrote shell scripts. I was back to shell script land for compiling my C and C++ code to get it in there. That needs better support for that, at least from the tools community. You can't invoke Node.js from Java, right? So if I have some Java code that I want to call off into some JavaScript code and I want that JavaScript code to use an NPM module, well, you're sort of out of luck. You can try loading the JavaScript files directly, but you can't really take advantage of that Node.js require up at the top that pulls in all of the dependencies and transitive dependencies. So if you want to use Node.js libraries, you kind of have to have the Node.js stuff, then invoke the Java code. R and Python support is experimental, which explains some of the bugs that I ran into with R. The Python C API is incomplete, so there's practically no, at this time point, there's practically no packages are supported. You can install NumPy, and that's about it for right now. I was actually trying to get an example working with scrapping, probably dumped around 6 hours into trying to figure out how to get that to work and wasn't successful. So it's still early. So GraalVM is still fairly new. They're still working on getting some of the different languages supported, so not everything works yet. So JavaScript works out of the box, but R and Python are a little bit, R is in better shape than Python. Python, as I mentioned, they're still implementing the API. The documentation is still a little bit rudimentary, so you're kind of like glancing over blogs and trying to find examples that work is kind of a challenge. There's also ongoing changes to the GraalVM, so they're not necessarily backward compatible. As I mentioned, I ran into a problem with Node.js invoking Java, where I had to run it in headless mode, otherwise the process would just seize up. And it was random, so the first couple of times I ran it, I had no trouble, but then suddenly it just would freeze on me. I was pulling my hair out until I got a dump and noticed that I was going for a graphics file to put in the dock. And it takes lots of trial and error to get things to work. The last example with the road races, my original goal was to have R pull the code out from a website, scrape it using the fixed width function in R to pull in the data into a data frame, and then hand that over to Java, except I have yet to successfully get that data frame to move into Java land. I don't know if it's my R code or my Java code, but the documentation is a little bit sketchy on that, in that area. So in terms of best practices, if you have code that's going to be running for a while, use startup in singleton. You can limit, if you're allowing different scripts to be executed, you can limit and control the scripts, so you can restrict whether they can access the file system, you can restrict what they can do, so they can't go run amok and change your code. And also add that thing that I demonstrated where you monitor for runaway scripts to control it, to make sure that the scripts, languages that you're invoking from Java don't run away on you. In addition with this, yeah, so those are the best practices to get started. It really is a learning curve. I've provided all of the examples along with some starting code, so if you want to start deploying code to an EE container using GraalVM, check out my GitHub project, which has all the examples from this presentation. You can download that and be up and running within a couple of minutes. Resources, right now most of the discussion is actually on something called Gitter, which I had not heard of until experimenting with GraalVM, but there's a Gitter community where people are posting questions. It's basically like Slack, so that's where you can get your questions answered or not. There's also a Medium GraalVM blog, which has a lot of good information. It's run by the guys over at Sun, so there's a lot of good information getting posted to that on a regular basis. And then there's a pretty good tutorial wrapping SQLite. The blog write-up is all in Russian, but you can look through the code and it provides a really good template for wrapping like native C libraries. So he actually went off, with his blog entry to go over how to wrap SQLite and access it from Java. So that's a really good starting point if you're looking at interacting with C++ and C code. So with that, if anybody has any questions, thank you very much. I'll take questions. Got 2 minutes. Yeah, Java 8, they do have builds for, I think, Java 11 and 12. So there's some later versions, I think, available in pre-release up there.
What is the support for JavaScript features like, code unification and, fetching all the packages and making somehow?
Okay, well, all of those things actually do work, right? So you do have NPM, so they do provide NPM and a node implementation. So my example here, I was actually using NPM. So I had my package JSON, it did reach out, you look in the directory, when it checks out the code, when it builds the code, I would, for my script, I ran, the node commands and it sucked down the packages and everything. So the minifications, you just would use all the same tools that you use over in your JavaScript land to do that. So all of your same tools should still work.
What do you think is the stronger side of GraalVM? Is it compiled to native code or its interaction with other languages?
What's that?
What's the stronger part of GraalVM offering? I mean, is it native code or interaction with other languages?
So it actually, well, I'm not an expert in that part of, in terms of how GraalVM is implemented. It actually is compiling stuff down to native code. It's using a bitcode interpreter underneath the hood to do that. So it's actually, it's not compiling it down to byte code.
I mean, just looking at the examples with multiple languages, I have a question. Why don't you just write in its own language, using its own ecosystem, and then communicate with Java using REST, for example?
Well, no, you can. So you can write, you know, all of your Python code is exactly how you'd write Python code, right? All of your Ruby code, so you're going to use Ruby code, use Ruby gems. You treat Ruby as if it's Ruby, and it runs just like, in fact, you can just run Ruby code like you would using the regular Ruby interpreter with GraalVM.
Yeah, but you mentioned the build system is kind of you use JavaScript.
Well, yeah, for the build tools, because I don't have a good solution for that, because I'm trying to interact with multiple languages, because most of the time I'm writing in Java code, so I'm either using Gradle or Maven, right? Or if I'm over in the C++ code, now I'm trying to combine, you know, an example, a Java EE code where I want to package up a WAR file with, you know, C code output. So that's a little bit dangerous. I have not, you know, gotten that part of it down yet, right? And probably I should have used, I think Gradle has better support for multiple languages, and I know that there's some Gradle plugins, but I haven't had a chance to play with them yet. Okay, if there's no other questions, thank you.